I hope you guys had a wonderful week. I'm trying to set up my environment and then I'll share my screen. Um, a couple of announcements before I start. Um, let's all try and improve our communication skills. So you need to tell me stuff that's happening to you beforehand so that I put that into consideration. If you find any reason why you won't be able to do something before the due date, kindly tell me at least 3 days before that date so that I know it's close to Janine. So when you wait until the last minute and then you tell me, I will not consider that. If you wait until it's 2 hours or 10 hours to the due date and then you tell me, then I will consider that. So let's improve on communication skills. One of the reasons you're passing through the university is not just to get the practical skills of physics, biology, chemistry, project management, and programming. You also should improve in character and in learning. So let's try that. Um, so back to the business of the day. So we're going to be looking at services today. One moment, please. So according to this, guys, this is from this is what I usually use. Fabric. They kind of gave a very brief overview of all the building blocks of domain-driven design. So according to them, they say essentially a service is an operation or form of business logic that doesn't naturally fit within the realm of objects. In other words, if some functionality must exist, but it cannot be related to an entity or value object, it's probably a service. So what this means is your service primarily holds your business logic. All the business logic that you have in your particular domain or problem space that is not tied to a particular entity should be in the service. But the first one would be it's naturally advisable to put all business logic in the service, whether it's tied to an entity or not. You just know that your services contain all the business logic. And a service is stateless. Okay, this is a brief definition of or the difference between a stateless and a stateful application, which can be drilled down to the service building block of domain-driven design. So it says stateful and stateless applications store data from client request on the server side itself and use that state to process further requests. It uses DB for storing data at the backend, but session information stored on the server itself. Now, this is an example. When a user sends a login request, it enables login to be true and user authenticated now. And on the second request, sorry about that, and on the second request, the user sees the dashboard. Stateful applications do not need to make call to the DB a second time as session information is stored on the server itself. So that's a stateful application. Stateful application stores data on the server itself. A stateful service stores data. It doesn't need to consistently go to the database or to the backend data store to get data. And that's the major difference between a stateful and a stateless. Now, a stateless service does not store information. While stateless applications work in different ways, they do not store any state on the server. They use the DB to store all the information. Your database is stateful because at a point in time, your database contains a particular data at that uh, time. So that's called stateful. So it says typically a user requests login with credentials. Any of the server behind LB process the request, generates an authentication token, stores it in the DB, and returns the token to the client on the front end. Now, this is an example of a stateless service. So this application requires a user to log in using the login credentials. So when the user passes the login credentials and gets authenticated, the server generates an authentication token and stores it in the DB and then returns that token to the front end. That means the service does not have that token. It just returns it. It takes the request and then returns with a response. And it doesn't store any data. That's what we mean by stateless. Although stateless applications have one extra overhead of the call to DB, these apps are amazing at horizontally scaling, crucial for modern apps which might have millions of users. So we are going to be looking. So they are very. If you open Google and type stateless service, you would see the difference between all this, between stateless and stateful. In stateless, server is not needed to keep the server information or session details to itself. That's the important thing. And in stateless, server and client are loosely coupled and can act independently. We're trying to achieve the highest form of abstraction, and that's why we know what we need to stateless service. So I hope you guys understand what stateless and stateful means. In summary, stateful preserves or contains information about the state of an application at each point in time. So a stateful service contains information. It doesn't necessarily need to go to the database to look for information. But for a stateless service, it doesn't store any data to itself at all. It just takes a request, takes it to the server that performs the computation and stores the computation in the database, and then returns the result of that computation to the client that sent the request. It doesn't store anything to itself. It doesn't store anything on the server. It just takes a request, processes it, gets the response, and gives it back to the user, and all the data is gone in that service. So your service layer in the building blocks of domain-driven design is stateless, meaning that it doesn't store anything to itself. Let's look for another definition of stateful. See how this guy talked about it. Okay, so domain service. We have already, this according to Vadin. Vadin is a framework on Java. We have already mentioned that both value objects and entities can and should contain business logic. However, there are scenarios where a piece of logic simply doesn't fit into one particular value object or one particular entity. Putting business logic in the wrong place is a bad idea, so we need another solution. And the solution is domain service. So it says the following characteristics form your domain service. They are stateless. They do not store any information to themselves. They are highly cohesive, meaning they are specialized in doing one thing and only one thing. Point to remember. They contain business logic that does not necessarily fit elsewhere. Very important. They can interact with other domain services to some extent with repositories. So it says here that they can interact with other domain services. They can also interact with other repositories to some extent, and they can publish events. In its simplest form, a domain service can be a utility class with a static method in it. More advanced domain services may be implemented as single things, and that's what we're going to be doing today, that have other domain services and repositories injected into them. So let's go back to where's my IntelliJ? There you go. Let's go back to our application. So up until now, we already have entities, factories, and repositories. So the beautiful thing about a service or the service domain, or sorry, the service building block of domain-driven design is it somehow looks exactly the same as your repository with added features, and the added features are your business logic. For example, your repository here is helping you persist value objects or maybe entities and aggregate routes to a particular data store. And the data store we implemented here is a, a set. But now, how do you expose this this particular implementation? We can only do unit testing on it directly, like we did last week. We did unit testing. Sorry, not on the factory, on the repository. This. But again, we want to expose this to the user so that a client can be able to send a request that finally hits the repository to save a particular race. So that's why we need a service. And this service is going to be stateless. It's just going to take the request from the user and pass it to the backend. And the backend here is the repository. And by backend, I don't mean data store, I mean a server, your middleware, if you want to call it that. So we'll start by creating the package for service. Call it service, all in small letter, not plural. So we want to create a service for race repository, which has been implemented here. So we need to follow this naming convention again, and we can see that your race has create, read, update, delete, and maybe get all, same as your gender and every other thing. So we also need to expose those common operations in the service. So we'll start by having the main service interface called iService. Bear in mind that this is just a naming convention. It may not necessarily be called iService. Even here, iRepository, this I just stands for interface. You can name this anything you want, provided it's explanatory. So this iService will contain the same thing as this guy. It's a service, and it's a service that exposes the repository. If you're following, please try and follow. So this is the main service. Then we're looking at creating a service for race repository, and race falls under the demography package. So we will create a demography package, demography dot race service. And sorry, it's an interface because it looks exactly, it's going to the interface looks exactly like the repository. So if you've understood what the repository is, then your services should just be a walkover. So as usual, this is going to extend the iService, and the domain we're looking at is race, and race is uniquely identified by an ID with data type string. And this race repository here has a get all, so let's also include that in our service. And let me close all this so that it doesn't confuse us. So we have a main service that has all the most common operations that you do or that is exposed, that you need to expose in the repository. Then we have a package called demography that has race, and we're following the convention of our packaging principles here because the race is under demography. So that's why we have demography here. And then we have the service for race called race service. And this is also an interface that can contain unique operations, and your business logic can now come under here. Unique business logic as race. Now let's create an implementation which is going to be inside the folder demography impl, and it's called race service impl. And this is a concrete class that now implements the race repository. Sorry, the race service. And like these guys said, they advised that for more advanced domain services, we should use singleton. And you know why we need singleton? Because you need one and only one, the same explanation I gave you here, why this was implemented as a singleton. You need one gatekeeper to coordinate access to your repository. Same way you need one gatekeeper to coordinate access to your repository. Let me say that again. You need one gatekeeper in the repository layer to coordinate access to your data store. That's your database. And then your service needs one gatekeeper that coordinates access to your repository. So we are going to implement singleton here. And because I am lazy, I'm just going to copy this, put that here, and then start changing. This is going to be race service. Now we don't need the database here because your service should not have access to your database. It should have access to your repository. sorry about that. So this, your repository is not going to be, you're looking at race repository, and then you call it repository. And this is going to be the constructor for that. So we have to change that. And now we don't need to initialize the database here. We just need to initialize the repository. If repository equal to race repository implementation dot get repository. You need to remember that. You need to remember that the repository does not have uh, a constructor, since it's also a singleton. Then this is going to return a REST service, and this will change to get service. And we're checking the service in this case, not the repository. So it's a single thing for your REST service implementation. Now the difference between this and a repository is, and which you need to understand well, your repository has access to your database. Your repository exposes a static repository object, which has to be a single thing. It needs to verify that it's null before it instantiates it. And when it's not null, it always returns that one and only one instance. And when you're instantiating your repository, that is when you also need to instantiate your database or connection to your database. In this case, we're using a set. That's what this does. But the service now should not have access to your database. It now links to your repository. So your service exposes a static service repository, sorry, a static REST service called service in this case. And then it has, when you want to get the service, it checks to see that that service is null. If it's null, then it instantiates that class, which is this. And the process of instantiating that class, you now need to get an instance of your repository. And that's all. And the service is usually easy. So in this case now, for the get all, you just need to call repository.getAll. For this, you just need to call repository.create and pass in the race. And then the read also, repository.read, pass in your ID. Update also, this.repository.update, race. Then delete this.repository.delete. Yes. This repository is complete. This service is complete. You see that this just gives you, the service layer gives you access to the repository that you can now use to call whatever operations you need. And then if you have any business logic that you have stated in the REST service, then you implement them in your REST service implementation. And this is actually all about service. So to test this, we need to create a test case. We're using JUnit 4, and you want to test that, and the delete. As usual, you would want your stuff to run sequentially, the create first, and maybe the read, followed by your update, and the get all, and then finally delete. Now, delete, in some applications, you don't necessarily have to delete. And I'm just showing you the CRUD in this case. And for these things to run sequentially or in alphabetical order, you need to put the annotation method order and pass in name ascending as the method sorter. Then you need to get, this will also look exactly like that. So we need to copy this. You don't need to copy it. I'm just copying it because I'm lazy. So this is race service. We have service here. And this now calls the race service implementation dot get service and a race. So the get all comes to set of race. I'm trying to accept the form. Expected is 1, actual is 1, and default is race size. And do this if you want. And create. Come to race from creation. As usual, we test to see that they are the created and this one are the same. Same thing as read. I'm just going to copy this. Copy. Service there, and then delete. So this is a test case for our raise service implementation. So we need to get access to the service which we want to test, and it's a single thing. And then we have a raise that we built using the factory that we want to send to the repository. So what this create does, what this service does, this service is stateless. You see, it would not save anything. It just takes the raise and sends it to the create method of that service, which in turn calls the create method of the repository. And it's in this case that you would now save in your database there. And then it returns the raise. This returns the raise to the raise. Where's that again? Sorry. When it's being created here, when it was created, it returns it to whoever called it. And in this case, the raise test, raise service is the one that called it. So it returns it here, and this also returns it to whoever called this case. Our client is the test case. That's why you have created here. So when you run this, it first of all calls the repository that now saves into your database. So let's see if this works. So see, it's running perfectly well. If you want to see the steps or the process flow, you can do a debug. Let's do a debug on create. Let me put a breakpoint there. How do you do a debug? You right click there and say debug. Then we see that it starts from our arrays. This is the test, this is the client. So you use any of this. You can step over or step into or step out, but in this case we want to step into and see what this guy is calling. So let's step into. We see that it's calling this service. Now this is the service that is stateless, and the race here is that. Then we'll also step into that because this service is now calling the repository, and we step into that. We see that we're now in the repository with the same race, and this guy now saves into the database, and now this database size is 1, and then it returns that race back to the whoever called it, and now back to the service. The service is not going to store it, it's going to return it back to the caller, and the caller is the test case. In this case, that's this, and the caller now does whatever as the client and displays it. So that's the way it goes. So now your service has one and only one functionality. It takes the data and sends it to the repository that does whatever it needs to do and returns a response to the service that sends it back to the client. In this case, the client is our test case. So the major weightlifting happens in the repository, and the service is just exposing that functionality. That's what you say the service is doing. Now, if there's a business case that says, get me all the what's a business case under race? I'm thinking of a business logic. Okay, let's say there's a business logic that says you need to get all the races that start with A. All the races that start with A, like African, I don't know any other that starts with A. Okay, let's assume that's a business logic. So you need to put that functionality here. So since we need to get more than one races here, it's a collection, so it's a set. And you say get all starting with sorry, A. Now you need to implement it. That's one of the uses of an IDE is that it shows you your possible error and points you where you need to implement. So you need to implement it here. What is that? What is it? There. So in this case, you can either there are many ways to solve this. You can do not absolutely nothing in your database and the repository layer and do everything here. First of all, maybe you decide to first get all the races that has already been implemented. Races all to get all. Now this is we're using this already, get all. So when you get all, then you now need to look through for race is in races. If race dot get we get description and let's dot train dot starts with A. So since we're using a small letter there, let's do lowercase. Now we need to build the one that we want to return. Set um, I don't know what happened. I think I lost connectivity somehow, but I'm going to reshare my screen again. I really don't know what happened, but yeah. So I was talking about, if, let me start afresh. If there's a business case that says you need to get all races starting with A, you can implement that in your service. And when you put that here in your interface, then you need to implement it there. So I started the implementation by saying there are two ways. One way is to we use the get all, which is up here. So this gets all gets everything in your database via the repository. And then I now loop through it and I find the description. I trim it to take away trailing spaces. And then I convert everything to lowercase and then checks if it starts with A. So if that happens, then I need to add it with I need to add it into my data store of races with A. Then I return that. So this is one way. So this is a business logic implemented on the service. You see, it still doesn't store anything. It just gets this, performs a computation on it, and then returns that result. It doesn't store it. So this is one way. Another way might, if this get all is expensive, for example, you have a million record in your database. So it's going to be impractical to get the million record and start looping through it. Then you do this directly on the database. You go to your repository and add this same thing. Where is that repository there? And then you implement it in the implementation, in concrete class. And in this case, you can now do a simple select all from database where description starts with A. So in this case, you can just do the same thing you did, uh, whichever way you want to implement it based on your data store, it can be implemented here. Then you've now succeeded in moving this functionality. There are too many things open here. You've now succeeded in moving this functionality to your repository. That means you'll now be calling this.repository.getAll. It's another way of doing it. So when the computation that you're doing on the service is expensive, consider moving it to your repository. But in this case, it's not expensive for now because there are how many races in the world? It's not up to, I don't know. Yeah. So let's not just move it for now. But that's the gist of it. Do we have any question? And remember, if you have questions, kindly just click on the raise hand button and I'll call you because I'm not looking at the chat screen for now. Any questions on this? So this is the story around your service. Your services are stateless and they do one and only one thing and they contain business logic. So it looks like a repository. It has got its own main service like like that, which is an interface. And then it has packages that contain interfaces related to whatever you're doing. In this case, we're talking about race. And then we have another package in that package that implements the interface. So when you open this, it's just the most common services that you want to expose, which is create, read, update, and delete. And then this specific one has get all, and it also has implemented a business logic. Oh, this one implements a business logic, which you can see in here. So this is a business logic specific only to race. So this just says get all the races that start with A. And I told you there are two ways to do it. One is to do the computation directly here. But if the computation becomes expensive that you cannot do it on a service, since that the service is stateless, consider moving it to your repository and then calling that whatever here. Is it clear? Do we have questions? Yes, Mr. Chris.
So I just have a concern. I have used ASP.NET Core and repositories are used as services in applications. I wanted to ask, can a repository layer of an application be considered as a service?
Okay, hold on. Yeah. So, sorry for that. Your question, Chris, is can your service be used as can your repository be used as a service layer? Well, there are many implementations of this. Um, there are many implementations of domain-driven design in different platforms or on different uh, by different vendors. But I'm teaching you the basics of it as described by this site. What is that again? This. It says domain-driven design has got all these uh, building blocks. So they all correspond to a particular thing and they've got their uses, and then I'm showing you how to implement this on a code base. So don't confuse that with a particular vendor's implementation. Just know the basic functionality of your entity and what it does, and the factory, what it does, and the repository and what it does, and the service with what it does. Some people might say this service is not needed, so you delete this layer and then expose this. But when you have a business logic, you're not doing it directly here, which sometimes may be cumbersome. But these are all the layers of build of domain-driven design. Did that answer your question, Chris?
Yes, it does. Thanks, sir.
Yeah. Any other question? Any other question? Okay. So that's your next deliverable. Your next deliverable is to implement the service building block of domain-driven design on your group project. So as usual, the group lead is going to start with creating a service package and then creating the unique interface and then implementing one that would have an interface and an implementation. And then every other group, and then he'll assign issues, he'll create issues and create a milestone, assign the issues to the milestone, and assign the issues to the group members, and then each group members will tackle their own issue. So be careful not to replicate the implementation folder. For example, I have under here, I have race here. If I have any other thing like gender, you see race and gender fall under the demography. So it follows suit that I'm going to see race and gender here, and I'm not going to have a duplication of the implementation. It's going to fall under that too, because this implementation package falls under that. So don't duplicate this inside a particular package, and then we're good to go. So when we get to this level, we're almost there in the design of our application. And you can see that when I started this class in the year, I told you we're looking towards developing microservices and exposing them as stateless applications, stateless endpoints. So you can see we're achieving that here by having this microservice. We can expose this create service that requires you to send a race, and it does one and only one thing, just create the race and returns it back to you if it's successful. So this is a microservice on its own that we're going to see how to expose pretty soon. So your next deliverable is service. I hope you guys now know how to do that. Yes, Mr. William?
Can you hear me?
Yes, I can.
I just want to ask about the assignment submission. What if we all submitted at 10, but then someone decides to change the code after 10, and then they push the changes? What happens to our code? I mean, to our marks? Can we update and then?
Who is the someone?
Sorry?
Is the someone the group lead?
No, a group member who maybe forgot to add code or something.
Well, did the group lead pick it up?
What does that mean?
So I'm saying the group lead is responsible for merging the project, the pull request from his, the pull request from his group members, right? So when a group lead gets a pull request, he needs to verify the content of that pull request.
Yeah, the group lead in our project just lets the merges happen, just like that.
Interesting.
Okay, so it shouldn't be like that. I see. Thank you.
Mr. Ross?
Hi, sir. I just have a request. Based on what William said.
Can
Is
you
it possible?
can you can you increase your volume? I can barely hear you.
Can you hear me now, sir?
Sorry?
Is it better now? The audio.
Okay. Yeah, continue.
I was saying, based on what William is asking, is it possible that you can do that demo of setting up the security for the repo, so that the group lead is the only person who can accept pull requests?
That has already been done. Check one of the videos. You'd see that has already been done by one of you.
Okay, all right, no problem. Thank you, sir.
Yeah. Any other question? Any other question? Comment? Yes, Mr. Veneza.
Hey, hello sir, how you doing?
Fine, thank you.
I'm sure you probably answered this question before, but I just need more clarity. With the service layer, why do we really need it? It seems like it is exposing the functionality of the repository, and why don't we just expose the repository itself?
The repository is only responsible for saving persistent data, right?
Yes.
It shouldn't be responsible for doing any other thing apart from persisting and retrieving data. So when you expose that repository, if you have business logics that you need to implement, where will you implement those? You need the service layer to implement your business logic. That's one reason. The repository stores information, so it's responsible for persistent data. Your service is stateless. It just exposes things and then sends the request to whoever needs to perform operation of that request. And another reason is an extra layer of security on your application. The service layer provides that. And you can see here that this is again some reasons why you need repository and the service layer.
All right, I see. Thank you.
So any other question? Any other question? Okay, any comments? Yes, Mr. Sean. Sean? Okay, in the absence of any questions or comments, thank you for your time. Have a lovely day.